Hello and welcome back. Well, we've got a bit of progress on the sub amp. We've got a bridge rectifier on there. We've got a couple of circuit breakers for the moment instead of fuses on the AC going into the bridge rectifier. We've got some bleeder resistors and also equalization resistors. With these capacitors being in series, you need some resistors across each one to equalize the voltage across each one. So that's what they're doing. We've just got 220k. That's what I found in my spare image jump box. You use anything from 100k, 200k and upwards really. They don't really serve as bleeder resistors because these are such big caps, but eventually they'll bleed it down. Did have a problem. I've got it connected to one of these amplifier modules, and we did have a problem when I first powered one of these up, in that as soon as we put a load on the output, the voltage dropped and it was just sucking loads of current. It was basically oscillating, really low frequency oscillating. But I think I managed to sort that out, and so this module here is now working. That's all good. The only thing that's of concern is that these output transistors here are getting very hot. Too hot for comfort really to put your finger on, and they shouldn't be really, I don't think, getting that hot just sitting there in quiescent mode. So we really need to get something like this on here. The main problem I have is trying to, obviously they've got to come out. If we could get that to sit like that sort of thing, and with very short leads, then that'd be good. But then we've got the problem in future, if we have to get to this board, then we can't get to the board. So I thought about mounting it something like that, because remember there's two boards and two of these, so maybe I could make it like a sort of like a tunnel. We're making a bit of progress. Just got one transistor off just to have a look at it and work out how we're going to mount everything. This has got a Motorola port number on it, but as far as I know, these are 2N3773, and they seem to have been used pretty much ubiquitously in a lot of amplifiers of this era. I would think this is 80s. These modules and this that came out of this mixer. But looking at it, Jesus, they don't seem to be very well made. I mean, they're very skinny things. You know, the body of the TO3. If you compare that with this similar new old stock 2SC1116 Sanken, look at the thickness of the dies, a lot more meaty. And so, because it's a lot more meaty, it's gonna deal with more heat, isn't it? A lot better, dissipate heat a lot better. But I've just bought some, funnily enough, I've just bought some 2N3773s for a quad 405 current dumping amplifier. Well, it's going to be a clone. I've just got the PCBs, and they're about the same. Very wimpy, horrible TO3 package. Still, if they do the job, then you know we should be all right. Anyway, as to how we're going to mount these, this is the plan. This is the back plate that came off the mixer. So if you use that at the bottom, and just shove them to the back and give you an idea. So one will sit like that. And the other one will sit like that. You can see that. It's a bit hard to hold this. Right, where's my amplifier module? And then we can mount Obviously this is going to go in better without those horrible heat sinks there, although we've got these heat sinks here, but I'm not sure if they'll be better on the same board. I don't know. Anyway, they can slide in there, hopefully. If I turn it the other way around, it should go in. No, it won't. I'm going to have to take these brackets off, but they should go in there. And so then the leads, the flying leads from the board to the transistors mounted on this heatsink should be short-ish. Well, I've managed to mackle together a solution to mount these heat sinks and boards, although it isn't very elegant. As you see, we've got the two heat sinks vertically, and I've used the mixer back panel, like a extended C channel, chopped that into bits. Got one at the bottom there, just to hold this together, hold the two heat sinks at the bottom together. And as you see, we've slid that PCB into there, and the PCB is mounted on some little, mounted on this sticky rubber stuff to stop any track shorting. And as you come around here, we've got two of the output transistors mounted here with the thermistors going into pins. These pins go all the way through. So then it's just a matter of running these wires over to these holes here, pop them through, and then this bottom board should be done. Only problem I can see is A, getting it together, B, getting access in future if something goes wrong, and what have you. But yeah, well, we'll just have to deal with that when we get there. Hopefully we won't have to take it to bits. Right, well, that was a bloody nightmare getting that in, but it's in. We've just got to check it. So I don't know if you can see in there. Yes, you can. There's it all wired up, all four transistors, all four output transistors wired up, and all three thermistors wired up. Are they wired up in the right order? We do not know, so I've got to check that. And my back's bloody killing me because I stand up at the bench, I don't sit down, and I'm in desperate need of some caffeine. Need to get a black coffee. It's some days later here in not so sunny Lincolnshire. We've got both the boards into the heat sinks, they're mounted. Bit of a bodge job. I just got some bits of wood put into one of the fins and then screwed through with a self-tapper. Not elegant, but does the job. They're mounted on some rubber heat sinks, some rubber pads, as I might have mentioned before. After some false starts and stupid mistakes, i.e. being tired and shorting out the output to the positive rail of one of the channels, both the channels are working. I've been mucking around with various input transformers to try and get a split signal, i.e. one that's 180 degrees out of phase with the other, so that we can bridge these two channels. Problem is, a lot of these input transformers are designed for a balanced input in and unbalanced out. So like this one, for instance, is a really nice big transformer, which is what we want. We want a big physical heavy transformer because like more iron means that it's better at low frequencies. However, if we run this the opposite round to how it was intended, I balanced in and unbalanced out. If we run it the other way, I unbalanced in and balanced out, if you understand me, to get the two signals out of phase, then we lose a lot of signal. So that's 100 to 1. So we need to drive these amplifiers, we need about a volt. So that means we need 100 volts in to get 1 volt out. Well, that's just ridiculous. Looked at a few. These are the input transformers that came out of the mixer, which these boards originally came out of a Shaw mixer. They work okay, but again we've got a loss of signal. So there's got to be a better way of doing this. So I've decided to do it with using a one transistor, like a transistor equivalent of a cathode phase splitter, which basically means just equal loads on the collector and emitter. That will give us our out of phase signals. However, we've then got problems in that all this circuitry, the low pass filter and all the rest of it, is going to introduce phase differences between the signal going in, signal coming out. That means different phase relationships with the main speakers and the subwoofer, which is problematic. I won't go into all that just now, I'm still researching that, and it's bending my mind. It really is bending my mind. This speaker technology, there's a hell of a lot more to it than meets the eye. Yeah, okay. Well, I think that's about long enough for the video now. So we'll end it there. I'll have a bit more of a muck about and take a bit more video, and hopefully see you all soon. Thanks for watching. Ta-da now.